Again, welcome back to calculus class. In these lectures, we are going to learn the concept of a slope as a ratio or as a rate in a real-life application. Also, we are going to learn how to write equations of lines that are parallel or perpendicular to a given point. So we start with graphing linear models. Here we say many problems in a coordinate geometry can be classified into basic categories. These two basic categories are given a graph or part of it, we should find its equation, or given an equation, we should sketch its graph. Now, for lines problems in the first category, which is again given a graph or part of a graph, we should find its equation, can be solved by using the point-slope form. Now, the point-slope form, however, is not especially useful for solving problems in the second category, which is again given an equation, we should sketch its graph. So we start with the concept of a slope-intercept form of equation of a line, which is always y equal to mx plus b. So ms will be the slope, and also the b is the y-intercept. Y-intercept means when x equal to 0, the value of b or the value of y will be the b, which is again the y-intercept. So now let's see an example. Here they say we should sketch the graph of each equation. And we have y equal to 2x plus 1. Then we have y equal to 2, and the second and the third, 3y plus x minus 6 equal to 0. So the first equation is very straightforward since we already have the point slope. So by looking at the question, we can see that the slope is 2 and also the y-intercept is 1. So this means when x is 0, y is 1, and also the slope is 2. So this means because the slope is 2, we know that the lines will rise 2 units for each unit it moves to the right. So when x is 1, y will rise 2 units, as shown in the following graph. So here we can see solving this problem again is straightforward because, as we said, the question is given to us as y equal to 2x plus 1. So we know the value of the slope and we know the value of the y-intercept. So y-intercept is 1. So this means when s is 0, y is 1. So that's our point here. And now since the slope increase is 2, if we move one step on the x-axis to the right, we're going to move y twice. So that's why when x is 1, y is 3. And all we need to plot a straight line is 2 points. So now let's assume we have the 2 points, we can just plot the straight line across it. So the second question said we should writing the equation y equal to 2. How can we plot this graph? So y equal to 2 means the slope is 0. So we can write it as y equal to 0x plus 2. So this means we have the y-intercept, but again, since the slope is 0, we are going to get horizontal line, which means again, the value will be constant, y2 throughout. Now we know with a vertical line, it's undefined. Then we will see example of that soon. So the last example is 3y plus x minus 6 equal to 0. So here we can begin by writing the equation to the slope-intercept form, such as the first example was given in a slope-intercept form, the equation. So here we look for the value of y. So here we can say 3y will give us, since x is positive, when you cross the equal sign become negative. When 6 is negative, when you cross the equal sign become positive. So we get 3y equal to negative x plus 6. Now, since 3 is multiplied by y, we are going to, when you cross the equal sign, it's going to divide. So 3 is going to divide minus x plus 6, which we get y equal to negative 1/3 x. 6 divided by 3 is 2. So now we have the slope-intercept form. And here, when we look at it, our slope is negative 1/3, and also our y-intercept is 2. So we can plot our graph now. So here we say that in this form, you can use the y-intercept, which is 0 and 2, and also the slope, which is negative 1/3. So our slope, our first point will be the y-intercept, which is 0 and 2. S is 0, y is 2. Now, since the slope is negative 1/3, m is negative 1/3, it's going to false. So here we are going to see that when x move up to 3, y will move negative 1, because it's negative 1/3 x. That is, the slope is negative 1/3 x. So x move 3 units to the right, y will fall down by negative 1. So now, next is graphing the linear models. Here we say that because the slope of a vertical line is not defined, as we said, the slope of in our previous lectures, we said that the slope is equal to the difference of the value of y when you take 2 points, and also divided by the difference of the value of x, because we know each point have x and y value. The coordinate is x and y. So if we take 2 points, then we get now, if we have a vertical line, it means what? The x value is the same. So any value divided by 0, there's no solution. So that's the whole concept here. Now, this is how the summary of the equation of a line. We can have the general form, which is ax plus by plus c equal to 0. Or the vertical line, x equal to a. Horizontal line means y equal to b. Then we saw the slope-intercept form, which is y equal to mx plus b. Or the point-slope form. Now, that will be our next category. So we saw the beginning, we are solving 2 type of questions category. First is the example we did, how to plot a graph. Now, second question will be, for example, a slope is given to us, and an equation is given to us, and we need to find a second line, either is parallel or perpendicular to the previous equation. So in this kind of question, we use the point-slope form instead of the slope-intercept. So slope-intercept form is good for plotting the graph, and the point-slope form is good for finding an equation of a line, or let's say a second line if the first line is given. And this will be either perpendicular or parallel. So here we have a parallel and perpendicular lines. So let's see the whole idea of these two. Now, if 2 lines are parallel, it means the slope is the same. So we can see the first line, the slope is m1. The second line, the slope is m2. m1 equal to m2. Now, with perpendicular means one line will intersect the second line and it will form a 90-degree, as we can see on this graph. So we have line 1 and line 2, they intersect, but they have 90-degree. Now, when 2 lines are parallel, they cannot intersect because they're going. So in this case, if 2 lines are perpendicular, it means the first slope is equal, the second slope will be the reciprocal and negative of the first slope. So let's say the first slope is m1, then the second slope will be negative over 1 over m1. So example here, we say m1 equal to negative over m2. The same thing, m2 equal to negative over m1. So what we mean here is that if the slope of m1 is 3, then the slope of m2 will be negative 1 over 3. So let's see an example here. Okay, so that's the theory here again. 2 lines are parallel, m1 equal to m2. If they are perpendicular, m1 equal to negative 1 over m2. Perpendicular means the 2 lines intersect and they form a 90-degree. So now, our second category of question, find the general form of equation of a line that passed through the point 2 and negative 1. And that are parallel to the first line, and also perpendicular to the second line. So we have the same line, but we are going to find another line that is perpendicular to the first line, another line that is perpendicular to another, the same line. So the first thing we are going to do here is to come up with the original, this is the original equation. We can change it to a point slope form. This will give us the idea. The main reason why we're doing this, we want to know the slope. So 2x minus 3y equal to 5 is the same as y equal to 2/3 x minus. So we got it. The slope is 2/3 and the y-intercept is -5/3. Our goal is the slope. Now the first question says we should find a second line that is para. So that means our second line also the slope will be 2/3. But if it's perpendicular, then our second line will be -3/2. So let's do the first A. The line is para. So here we say our slope is what? 2/3 if it's para. So now we need a second line, second point on the line. So we are going to use, as we said earlier, the point slope form, which is y equal to y minus y1 equal to mx minus s1. So when we're looking for equation of a line, we use the point slope form. Now to plot a line or a graph, it's good to use, as we said, y-intercept, slope-intercept form, where we know the y-intercept, we know the slope from the equation. So yeah, let's take a point. Here we decide in this graph we are using a point 2 and -1. So the A, y is -1, x is 2. And that will be our solution here. So we solve the equation and we get the general form will be 2s minus 3y minus 7 equal to 0. And also we can change it to any form or point slope form also if we want. So this is again when it's again para. Now when it's perpendicular, the only thing that is the same line to the same line. So the only thing that will change here will be the slope. So now we can see the slope is -3/2. So we plot our point and the slope. So we get -1 for y1, -2 for, 2 for s1. Now we are using the same point. When s is 2, y is -1, using the previous equation given and the equation of the line given to us. So we plug in and then we have the final solution. Will be 3s plus 2y minus 4. So that will be the conclusion of this lecture. So in this lecture, again, we learned the basic concept of coming up how to graph or plot a linear graph using the equation. And also how to find an equation of a line if a first line is given, and also we know the slope. And possibly we know the y-intercept also. So again, wish everybody the best and thank you.